ATR aircraft use three different types of electrical power current. Direct current DC for the majority of the systems, alternating current AC constant frequency for systems such as flight control sensors and fans, alternating current wild ACW variable frequency for systems requesting a lot of power like main hydraulic pumps or the propeller heating elements. DC and AC wild current are respectively generated by two engine-driven generators on each engine. AC constant frequency is provided by two static inverters which convert DC into AC located in the electrical rack. The DC and AC wild system can also be supplied from external power via two dedicated plugs located on the front lower right side of the fuselage at the first officer side window level. The 28 VDC power may be normally provided by two dual-function DC starter generators driven by the high-pressure HP compressor through the auxiliary gearbox. Each generator is air-cooled and is rated to deliver 12 kilowatts, 400 amperes, power under a nominal operating voltage from 27 to 31 volts. The nominal setting is 30 volts. A generator control unit, GCU, associated with each starter generator provides control for starter and generator operation. The GCU monitors the generator regulation by maintaining a constant voltage while any electrical load change. It also provides the starter generator fault detection and protection, such as over or under voltage, over or under speed, generator overload, current limiting. The aircraft DC distribution consists of two main buses, DC Bus 1 and DC Bus 2, a DC emergency bus, a hot main battery bus, a hot emergency battery bus, a DC essential bus, a DC standby bus, and two utility buses, Utility Bus 1 and Utility Bus 2. A set of contactors are used to connect the sources of power with the buses and the buses between themselves, according to the situation. A bus power control unit, BPCU, controls a main battery and an emergency battery located on the floor of the electrical rack provide additional power sources. A bus tie contactor, BTC, allows DC Bus 1 and DC Bus 2 to stay online with only one generator operating or when the aircraft is powered by external power. The multifunction computers MFC 1 and 2 control batteries operation and transfer contactors. A transformer rectifier unit, TRU, provides unlimited power from AC wild in case of dual DC generators loss. It delivers 60 amperes at 28 volts DC. The DC external power connection allows the aircraft to be supplied by a ground power unit, GPU. Between the generators in the engine nacelle and the electrical rack behind the first officer seat, the DC feeder copper cables are divided into two aluminium alloy cables to save weight. A feeder overheat detection system allows the DC feeder conditions monitoring. The AC constant frequency is provided by two static inverters located in the electrical rack. Inverters convert DC into AC with a 400 Hz constant frequency. The aircraft AC distribution consists of two main buses, AC Bus 1 and AC Bus 2, and an AC standby bus. Each AC bus is split into one 115-volt bus and one 26-volt bus. The multifunction computer MFC 1 and 2 and the BPCU provide controls for buses' operation and transfer contactors controls. A bus tie relay, BTR, allows AC Bus 1 and AC Bus 2 to stay online with only one inverter operating. Controls and displays of the DC-AC electrical system are located on the overhead panel on the main electrical power control panel in association with the system display electrical page displayed by default or on pilot request on the MFD. Observe the relationships between the main electrical power control panel and the system display electrical page and their meaning. The battery toggle switch. Off. Main and emergency batteries are connected only to their respective buses. On. Batteries only with no DC generator and no external power, no TRU. Hot main battery bus supplies essential bus, DC standby bus and AC standby bus through inverter 1. Hot emergency battery bus supplies the emergency bus. Amber arrow is displayed on System Display Electrical at the top of the connected hot buses label when the corresponding battery supplies network. Battery voltage is displayed in green if value is greater than 18 volts. Displayed in amber if value is less than 18 volts. This battery status has the highest priority. Not displayed, with an amber cross if status is not available. Override. This first override is automatic in case of dual DC generator loss, and the toggle selection on override position is just a confirmation. Ensures emergency and main batteries supply their respective buses. This position is protected by a toggle guard. The DC generator push button. On. the push button is depressed and extinguished. Corresponding DC generator status is displayed on System Display Electrical. A green arrow is displayed at the top of the label of the connected DC generator when the corresponding generator supplies the network. Off illuminates white. The push button is released. Corresponding status is displayed on System Display Electrical. Fault illuminates amber. The push button is depressed. Corresponding status is displayed on System Display Electrical page in the event of a problem and flight warning system is activated. The BTC push button. This guarded push button controls the DC bus tie contactor, BTC. Norm, the BTC push button, is released. In normal conditions, with both generators operating, the BTC is automatically opened by the BPCU, allowing isolated operation of both generator circuits. Note: in case of external power, hotel mode or single generator operation, the BTC is automatically closed, allowing interconnection of both generator circuits. Both main DC buses are connected and the green flow bar is illuminated. ISOL illuminates blue. The push button is depressed, meaning the BTC is opened. The external power push button. Avail, the push button is released. Avail illuminates green when DC external power conditions are met. On illuminates blue when the push button is depressed. It allows use of DC external power. Note: batteries must be set on prior to selecting the external power, and external power is the priority electrical power supply. The DC service utility bus push button. This guarded push button controls the connection and the disconnection of the DC service bus and of both utility buses to their associated main DC buses. Norm: the push button is depressed and extinguished. DC service bus and both utility buses are available unless a load shed signal is sent by the BPCU. Caution: when a near overload condition is detected, on System Display Electrical, the service bus is displayed inside an amber box, and on Attendant Control Panel, shed is illuminated. Off illuminates white. The push button is released. The DC service bus and utility bus 1 and 2 are disconnected from the associated main DC bus. Shed illuminates amber when a load shed condition controlled by the BPCU is present, and at least one utility bus is disconnected from associated main DC bus. The CCAS is activated and information is displayed on System Display Electrical. The X-Start Fail light illuminates amber. The flight warning system is activated and information is displayed on System Display Electrical page. On ground, during second engine start, the operative DC generator does not come online to assist the start between 10% and 45% of NH. The DC bus off lights. Extinguished in normal operation. Illuminated amber when associated main DC bus is not supplied, with flight warning system, activation and information is displayed on System Display Electrical. The battery charger push button. On. The push button is depressed and extinguished. The contactor is controlled by the MFC. It is controlled closed during normal operation. It is controlled open in case of abnormal system operation. Off. Illuminates white. Push button released. The battery charge contactor is opened. Fault. Illuminates amber. Flight warning system activation and information is displayed on system display electrical if an override or a failure is detected. The battery cell switch. It's an emergency or main battery amp selector used to check the selected battery by reading the ammeter. The battery amp indicator indicates the charge, CH, discharge, DCH, current of the selected battery. The indication on the battery amp indicator is linked to the battery cell position. The emergency supply indicator. Right arrow illuminates amber when hot main battery bus supplies essential bus, DC standby bus and AC standby bus through inverter 1. Left arrow illuminates amber when hot emergency battery bus supplies emergency bus. The guarded TRU push button. Extinguished and push button released with at least one engine-driven generator operative and AC Wild Bus 2 available. If AC Wild Bus 2 is not valid, the TRU is displayed in grey on the system display electrical. On illuminates white. The push button is depressed and arrow illuminates green. The TRU is connected and supplied from AC Wild Bus 2 and TRU status is displayed on system display electrical. On illuminates blue. The push button is depressed and arrow is not illuminated green. The TRU is failed or the TRU is not supplied by the AC Wild Bus 2 and in this case it is displayed as 2 grey circles in a blue square on the system display electrical. The inverter fault light indicator illuminates amber when an output under or over voltage of the associated inverter is detected, triggers the flight warning system and information is displayed on system display electrical. Note, when the inverter is available, the inverter fault light indicator is extinguished. Corresponding representation is displayed on system display electrical and a green arrow is displayed at the top of the inverter label. The bus off light indicator illuminates amber when AC bus is de-energized, triggers the flight warning system and information is displayed on system display electrical. Note, when the AC bus is available, the bus off light indicator is extinguished and corresponding representation is displayed on system display electrical. The guarded override push button. In normal situation, this push button is not used. It remains released and extinguished. In abnormal situation, this push button is used when on battery supply to transfer the DC standby bus and the inverter 1 from the hot main battery bus to the hot emergency battery bus. UNDV illuminates amber to indicate that DC standby bus voltage is lower than 19.5 volts. The override may be used as necessary. Override, when the push button is depressed, illuminates blue. And the DC standby bus and inverter 1 are supplied from the same source as DC emergency bus. Specific system display electrical symbology. A green rectangle is displayed for the DC emergency, standby or essential buses when buses' voltage are above 18 volts. UNDV is displayed above the DC standby bus when its voltage is equal or less than 19.5 volts. An amber rectangle is displayed around the DC emergency, standby or essential buses when buses' voltage are equal or less than 18 volts, and the green link between the hot battery bus and the corresponding DC bus disappears. On the left-hand maintenance panel, a rotary selector is provided associated to 5 indicators divided into 2 parts, DC and AC. On each indicator, a green arc indicates the normal operating range. In external power position, the DC panel indicates the DC GPU voltage and current. In generator 1 or 2 position, the DC panel indicates the associated DC generator voltage and current. In inverter 1 or 2 position, there is no indication on the DC panel, and the AC panel indicates the associated inverter voltage, load, and current. In main or emergency position, the DC panel indicates the associated battery voltage and load, while there is no indication on the AC panel. The DC service bus can also be controlled from the flight attendant panel. A DC ground service bus switch enables the control and display of the bus. If no power source is available to supply the DC service bus, nothing is illuminated on the switch. When the on light illuminates green, the DC service bus is available. DC service bus may be switched off by pressing the switch. In this case, a shed amber light illuminates. The shed amber light also appears in addition to the on green light when the DC service bus is used and an overload condition is detected. This is the same situation if the DC service bus is switched off from the cockpit. The aircraft is considered on ground, engine stopped, without external power, and battery switch in off position. In this case, the hot emergency battery bus and the hot main battery bus are directly supplied by their respective battery. The ground handling bus is automatically supplied by the hot main battery bus if the cargo door control panel door is open, or the refueling panel is open, or the entry door is open, or when the hydraulic aux pump push button on the pedestal is depressed. When the ground handling bus is supplied, a red ground handling on battery light on the cargo door control panel illuminates. The DC ground handling bus can supply on-ground, cargo door actuation, refueling, defueling operations, cabin entrance light and cockpit entrance light for 2 minutes, hydraulic auxiliary pump operation. When the GPU is plugged, the BPCU checks and monitors the electrical power. If the current is within acceptable limits, a Vale green light illuminates on the external power push button. Note, if the main battery is weak, the GPU cannot be connected to the aircraft electrical network. Automatically, the ground handling bus becomes supplied by the DC service bus, which is now supplied directly by the GPU. On the cabin attendant panel, the green on light illuminates on the DC ground service bus switch. Now set the battery switch in on position. The main battery supplies the DC essential bus, the DC standby bus, and the inverter 1 through the hot main battery bus. Thus, the AC standby bus is supplied by the inverter 1. The emergency battery supplies the DC emergency bus through the hot emergency battery bus. Amber arrows on the control panel indicate that batteries are discharging. In normal configuration, DC generator push button are depressed. Therefore, the amber fault lights are illuminated. As the aircraft is now powered partially with batteries, DU2 and 4 are supplied, and the MFD system display electrical can be seen. Depress the external power push button to use the GPU to power the DC-AC electrical system. The on blue light illuminates on the control panel and on the system display electrical. The GPU now supplies DC bus 1 and DC bus 2 through the BTC. DC bus off lights extinguish on the control panel, and on the system display electrical, the DC bus symbols are updated. Simultaneously, main and emergency charge batteries contactors close to supply their respective hot battery bus to enable batteries to charge. Therefore, the amber arrows extinguish on the control panel and on the system display electrical. DC standby bus is now supplied by the hot emergency battery bus. Inverters are now supplied by their respective main DC bus. The inverter fault lights disappear on the control panel and on the system display electrical. Inverter 1 supplies AC bus 1 and AC standby bus, and inverter 2 supplies AC bus 2. The respective bus off lights extinguish also, and symbol is updated on the system display electrical. Now, the DC service bus is supplied by the DC bus 1 and supplies the ground handling bus. Both utility buses are connected to their respective main DC bus. As DC service bus and both utility buses are supplied, the shed light disappears on the control panel and the bus's status is updated on the system display electrical. To start the engine, the GPU can be used or the main battery if GPU is not available or weak. Consider we are using GPU and we will start the engine 2 first. In starter mode, the DC starter generator cranks the engine until 45% of NH. Between 45 and 61.5% of NH, the DC starter generator has no function. A cooling period is observed. Prior to starting the engine, selecting a start position on the engine start rotary selector causes batteries to be disconnected from the battery charge circuits. Amber arrows are illuminated on the main electrical power panel and on the system display electrical to indicate that batteries are discharging and supply their respective buses. When start sequence is completed and the engine start rotary selector is set to off and start abort position, batteries are connected to their respective charge circuits and amber arrows extinguish. The DC-AC system is still supplied by the GPU because the GPU has priority over the generators. DC generator 2 is shown as faulty on the control panel and on the system display electrical because it is producing current but is disconnected from the network. Switch off the external power. The on light extinguishes on the control panel and on the system display electrical. DC generator 2 comes online and the DC generator 2 fault light extinguishes. Now the whole network is supplied from generator 2 only. The GPU can be removed and the external power status is updated. The engine 1 is started by the main battery and the running starter generator. This is the cross start. Between 0 and 10% of NH, only the main battery supplies the engine 1 starter. From 10 to 45%, the main battery is helped by the DC generator 2. Once the NH reaches 61.5%, the DC generator 1 comes online and the BTC opens automatically. The main electrical power panel is now dark, which reflects the normal operation of the DC electrical system. In flight, the ground handling bus is de-energized. The AC wild power is generated by two generators driven by the propeller reduction gearbox. Each generator is air-cooled and is rated to deliver 20 kVA power under a nominal operating voltage from 115 to 200 volts. The normal operating frequency range is from 341 to 488 Hz, when NP varies from 70 to 100%. A generator control unit, GCU, associated to each generator provides control and protection against over or under voltage, over or under frequency, voltage regulation, current limiting. The aircraft AC distribution consists of two main buses, AC Wild Bus 1 and AC Wild Bus 2, and an AC Wild service bus. A set of contactors are used to connect the sources of power with the buses and the buses between themselves, according to the situation. A bus power control unit, BPCU, controls main buses tie, load shedding, service bus, external power. Two bus tie contactors, BTC, allow AC Wild Bus 1 and AC Wild Bus 2 to stay online with only one generator operating, or when the aircraft is powered by external power. The AC external power receptacle allows the aircraft to be supplied by a ground power unit, GPU. Controls and displays of the AC Wild electrical system are located on the overhead panel, on the AC Wild electrical power control panel, in association with the system display AC Wild and hydraulic page, displayed by default or on pilot request on the MFD. Observe the relationship between the AC Wild electrical power panel and the system display AC Wild and hydraulic page and their meaning. The AC Wild generator push button, on. The push button is depressed and extinguished. A green arrow is displayed on system display AC Wild and hydraulic at the top of the connected AC Wild generator label, when the corresponding generator supplies network. Off. Illuminates white. The push button is released. The associated generator is de-energized and the associated generator contactor is opened. Fault. Illuminates amber with push button depressed and the flight warning system is activated and information is displayed on system display AC Wild and hydraulic in event of generator failure detection. The AC Wild Bus off lights extinguish when associated AC Wild bus supplied. Illuminates amber when associated AC Wild bus is not supplied. Activates the flight warning system and information is displayed on system display AC Wild and hydraulic page. The BTC push button. This guarded push button controls the AC Wild bus tie contactors BTC1 and BTC2. Norm. The push button is released. The push button is extinguished if both generators supply their corresponding bus. A green flow bar on the push button is illuminated in case of external power operation or single generator failure. In this case, BTC 1 and 2 are closed automatically, and both main AC Wild buses are connected in parallel. ISOL. The push button is depressed and illuminates blue. The BTC 1 and 2 are forced open, and status is displayed on system display AC Wild and hydraulic. The external power push button. The power is controlled via the BPCU. A veil illuminates green with push button released when the external power can be used. External power status is displayed on system display AC wild and hydraulic. On illuminates cyan with push button depressed when the external power is selected on. On the system display AC wild and hydraulic, the on cyan label is displayed and a green arrow appears on the left side. If the external power is not available and the push button is depressed, only the on cyan light illuminates. On the system display AC wild and hydraulic, the external power symbol becomes a cyan square with on cyan indication. Now observe the correspondence between the TRU push button on the main electrical power panel and the TRU representations on system display AC wild and hydraulic. TRU push button is released on main electrical power panel, the TRU is not selected, and AC wild bus 2 is invalid. TRU push button is released. The TRU is not selected and AC wild bus 2 is valid. TRU push button is released, the TRU is not selected but remains connected, and AC wild bus 2 is valid. TRU push button is depressed, the TRU is selected and AC wild bus 2 is valid. TRU push button is depressed, the TRU is selected but failed, and AC wild bus 2 is valid. TRU push button is depressed, the TRU is selected, and AC wild bus 2 is invalid. On the left-hand maintenance panel, a rotary selector is provided associated to 5 indicators divided into 2 parts, DC and AC. Regarding AC wild power, the rotary selector concerning positions are the external power, generator 1 and generator 2. In external power position, the AC panel indicates the AC wild GPU voltage, current and frequency. In generator 1 or 2 position, the AC panel indicates the associated AC generator voltage, load current and frequency. The AC wild service bus control is only available on the flight attendant panel. An AC wild ground service bus switch enables the control and display of the bus. If no power source is available to supply the AC wild service bus, nothing is illuminated on the switch. When the on light illuminates green, the AC wild service bus is available. AC wild service bus may be switched off by pressing on it. In this case, a shed amber light illuminates. The shed amber light also appears in addition to the on green light when the AC wild service bus is used and an overload condition is detected. The aircraft is considered on ground, engine stopped without external power and battery switch in off position on the main electrical power panel. The AC wild electrical system is not powered. An AC GPU can be used to supply AC wild buses, considering that it delivers a frequency within the AC wild frequency range 341 to 488 Hz. When the GPU is connected to the external power receptacle, the BPCU controls and monitors the external power. When the current is checked to be within acceptable limits, the Avail green light illuminates on the external power push button. Automatically, the AC Wild service bus is supplied. On the flight attendant panel, the green on light illuminates on the AC Wild ground service bus switch. Now, set the battery switch in on position on the main electrical power panel to use the AC GPU. Depress the external power push button on the AC Wild electrical power to use the GPU to power the AC Wild electrical system. The GPU now supplies AC Wild Bus 1 and AC Wild Bus 2 through the BTCs. AC Wild Bus off lights extinguish on the control panel, and on the system display AC Wild and hydraulic, the AC Wild bus symbols are updated. The AC Wild service bus is now supplied from AC Wild Bus 1. The AC Wild generator needs a minimum of 66% of propeller speed, NP, to deliver power. Following the engine 2 start, the NP reaches its minimum value of 70.8%. As external power has priority over the AC Wild generators, AC Wild remains offline and is shown as faulty. Switch off the external power. The on light extinguishes on the control panel and on the system display AC Wild and hydraulic. AC Wild Generator 2 comes online, and the AC Wild Generator 2 fault light extinguishes. Now, AC Wild Generator 2 supplies AC Wild Bus 2 and AC Wild Bus 1 through the BTCs. As one AC Wild generator is offline, the AC Wild service bus is automatically shed to avoid the remaining generator overload. The GPU can be removed, and the external power status is updated. Following the engine 1 start, when the NP reaches its minimum propeller speed, the AC Wild Generator 1 goes online, and the BTCs open. Each generator supplies its respective bus, and AC Wild service bus is powered back by the AC Wild Bus 1. The AC Wild electrical power panel is now dark, which reflects the normal operation of the AC Wild electrical system. In case of electrical system failure, refer to the Master Minimum Equipment List, MMEL, of ATA 24.
Your answer is correct. 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 Your answer is correct.